to the part 3 of learning drawing Lewis dot structure. In this tutorial, I will teach you how to draw Lewis dot structure that has more valence electrons remaining. Okay, and what do we do with the remaining valence electrons? Okay, after we distribute to the outside atom, and we will also learn how to draw the Lewis dot structure for ions. So to start off, let's use a very simple example: H2O. Okay, and what we will do is to follow the same procedure, and by now I hope you're familiar with the procedure, okay, the steps that we draw Lewis dot structure. So first we look at the hydrogen. We have one valence electron for each hydrogen, and there are 2 hydrogen atoms total, so that's why we put it here. And then for oxygen there are a total of 6 electrons, okay, from the oxygen. So the total valence electrons for the molecule itself, there are 8 electrons. So then we will draw we connect the hydrogen with the oxygen, and by this we draw 4 electrons already. So minus 4 electrons, and we have 4 electrons remaining. Now in the past tutorials we will look at the octet to see if it's octet, and we'll do the same right here, okay, to see the outside atoms are octet. For hydrogen, remember, is an exception because it can only take 2 electrons due to the limitation of the first energy level. So 2 electrons for hydrogen, 2 electrons for the single bond. So for these 2 hydrogen atoms, they have their octet already. Now, what happened? What do we do with the 4 electrons remaining? Well, if we cannot distribute the valence electrons to the outside atom, and very likely that the central atom is not octet yet, what we would do is to distribute these remaining valence electrons to the central atom. 1, 2, 3, 4. Okay. So we will put the 4 electrons in pairs, okay, to the oxygen. So this will use 4 electrons, and we have 0 electrons remaining. Now this is the key of drawing Lewis dot structure. For all the structures, you should use all of the valence electrons, because this is how they form the molecule. Okay, all the valence electrons should be used on drawing in drawing the Lewis dot structure. So now let's make sure that every single atom is octet. Hydrogen, okay, they are octet. Oxygen, 2, 4, 6, 8. Oxygen is octet as well. So therefore, this is the Lewis dot structure for water, H2O. So I hope you understand how do we allocate the electrons that's not drawn on the outside atom. Okay, what we would do is to put them onto the central atom. Okay, now this is a very easy one. Now what happens if we have an ion? Okay, let's look at a very simple example for ions. Okay, let's look at hydroxide, OH minus. Okay. Now, when we do the ions, you have to be very careful with the electron count on the valence electrons. For oxygen, there are 6 electrons, 6 valence electrons. For the hydrogen, it has 1 valence electron. Now, are we done here? Well, not yet. We have to take care of the charge. When we have a minus charge, that means there's an imbalance of between protons and electrons. And when we have a negative charge, it means there are 1 more electrons than the protons. So this combination of oxygen and hydrogen, they gain 1 electron from other sources. So therefore, we have to add this electron based on the charge. Okay. If there are 2 minus charge on this polyatomic ion, then we will be adding 2 electrons at the end. But in this case, since it's just 1 minus, we are going to add just 1 electron. So a total of these will be 8 valence electrons. So now we are going to connect the hydrogen and oxygen together. All right. So this would use up 2 electrons. So we have 6 electrons remaining. Now, the next thing we do is to fill up the electrons on the outside atom. Now you may ask, well, we have two atoms right there. So which one do we pick to be the central atom? Well, the answer is it doesn't really matter. You can pick either one. If you want to pick hydrogen as the central atom, then we look at the oxygen to see if it's octet. Well, it is not because it has only 2 electrons. So what we need to do is to put 6 more electrons around the oxygen to make sure it is octet. So we put 6 dots right here. Okay, so this is what happened if you consider hydrogen as the central atom. Now, what if you are the other case, that you consider oxygen as the central atom? Okay, let me go back. If you consider oxygen as the central atom, then we would just do the same thing as we did in the water example. That, well, if oxygen is the central atom, we will make sure the outside atom is octet. Hydrogen is octet because it only needs 2 electrons. It has 2 electrons based on a single bond right here. We have 6 electrons remaining to be drawn, and we have to use up all the valence electrons. So now we look at the central atom. Does the central atom have an octet? Well, it does not. It only has 2 electrons. So therefore, we will have to fill it up based on the number of electrons available. So we will put 1, 2, 3, 4, 5, 6 electrons. And we used up all the valence electrons available. And now we have the oxygen being octet. Now, are we done here? Well, not yet. Because if you look at this one here, it is more like a molecule with oxygen and hydrogen, the octet, but it doesn't show that it's an ion. So in some way, we have to show that it is a hydroxide ion rather than a molecule between oxygen and hydrogen. So to do that, this is why we put a bracket next to it, and we would have to, let me erase this part, put a charge outside the bracket, okay? Put a charge outside the bracket to indicate that this is an ion, okay? The charge indicates the charge of the polyatomic ion. So this is the drawing for the Lewis dot structure for hydroxide ion. Now for other ions, it will follow the same procedure. Just draw the Lewis dot structure as you were instructed in the previous parts. And what we do at the end is to put a bracket, and we put a charge as a superscript outside the bracket, because we have to show everybody that it is an ion. Without the bracket, without a charge, no one would know that this is actually an ion. Okay? So I hope you understand how we draw the polyatomic ions. In the next tutorial, we will discuss what it is and what it means by resonance structure, and how do we know if we have to draw if we have to draw a resonance structure. Thank you.